The big budget arena of Formula One provides a high-profile backdrop to a cutting edge of technology and innovation which moves further and faster than virtually anything else in the world. Even the aerospace industry, the crucible of scientific advance, for the past 25 years can't respond at the week-by-week pace demanded by Formula One. Inevitably, those demands are met in different ways by teams at different ends of the literal and financial pit lane. At one end of the scale are the cash-rich teams with only marginally more money than trophies and titles, who plough vast fortunes into research and development, and who always do well, even in adversity. At the other end are the poorer, often newer teams, whose entire budget for the season wouldn't pay the catering bill at McLaren.
It's certainly a small budget by Formula One standards, but I think there are 2 or 3 teams in our position who really have to watch the pennies and also have to cut back on certain areas that you would normally want to spend money on to do it properly. But it's just a fact of life in Formula One that for new teams and for teams which are trying to establish themselves, you have to run at a budget level which you can realistically achieve, rather than what you'd ideally love to have, because the sponsorship isn't thick on the ground whenever you're towards the back of the grid, certainly in the bottom half of the grid, and certainly while you're still establishing yourself.
New 1995 regulations have given all the teams a clean sheet start to the season, but in many ways that serves only to heighten the difference between the haves and the have-nots.
We would have still done it, we would have still come in, but there may have been more areas where we were behind. The status quo remains the same usually, whatever. Last year it wouldn't have made really any difference to us anyway, and this year we had to build a completely new structure and a completely new car, so whichever way the other rules went from safety terms wouldn't really make any difference to us, although it did allow everybody to start from scratch. But obviously the certain teams have information and data which always, no matter what you do, is valuable. But the technology has given us perhaps an advantage on small things, fly-by-wire, traction control. But then, I think if you look at Formula One now, there's no doubt that there are other things taking the place. And we know those are available, and we don't have them at the moment because of budget. But we need to achieve them. So it goes in the mix of F1, and you never stop it. It's like the performance. The performance now will come up to where it was. It's an ongoing process.
For the middle-ranked teams, the problems remain the same.
Again, it's about interpretation. To be honest, there's room to do a lot. And if you're a big team that has got a major sort of international backing, and you're willing to take a shot at something and fight for what you believe is interpretation, then it's very open. You can do a lot. But when you're a small team and you can't afford to upset some people, then you have to sort of back off a bit. You are shackled really, because you read the regulations with a different, you read the writing that's there, but basically you have to try and interpret into what somebody else at the FIA might think. And it's never really good when it's that way. I think, to be honest, the regulations would be better to be written, and be 10 times the amount there are, but then it defines them, and then it gives you room to actually manoeuvre. There'll always be that flash of brilliance, hopefully, that will bring the car up. But for the beginning of this year, I think everybody had to take a fairly sort of steady look at it, because there was such a big change. So they had to put themselves on a baseline to work from, see how the car reacted to the new regulations, and then I think you'll see the steps coming, later this year, early next year. I think you'll see big changes in the cars.
There's an old motor racing expression which says, there's nothing wrong with this that can't be fixed with a bucket full of money, but it's a bucket full of money usually best spent away from the racetrack.
If you look up the pit lane really and look at what you might suspect the budgets will be for the various teams, the teams with the biggest budgets are as a general rule, the ones in front.
That's what money and manpower do for you. You know, at the end of the day, they give themselves a baseline to work on. They knew they were going to change it dramatically. We're the same, but we can't run quite as fast as them because we just don't have the manpower or the money.
Formula One is represented as the summit of achievement, the ultimate progression through the ranks. But though that may be true of drivers like Coulthard, Hill, Alesi and Schumacher, who have all come up the hard way, it's completely different for teams and team owners. The fact is that most young drivers see Formula One as a goal. It's the aiming point on which their ambition is focused. But for team owners, that single-minded attack on a perceived pinnacle isn't always so clear-cut. Not every one of them dreamed of this moment, owning their own team.
No, it was never a goal. I mean, my goal was to be a driver, and like everybody, you adapt when you haven't got any money. And I sort of then went, what else could I do, which was the next best thing, and didn't like working for anybody particularly, so I started living it, if you like, through the team, and it progressed in achievements. When I started, the goal would have been Formula 3, but again, I couldn't raise the funding, and so we started off in Formula Ford, which I wasn't very excited about at the time, but you adapt, and when you're doing it and you're committed to doing it, it suddenly becomes the most important thing, and I think it's important that every formula has its own techniques. People should never underestimate formulas, because there's a lot to be learned in other formulas.
Pacific are at the Noah's Ark end of the pit lane where everything comes in twos. Big teams have 5 of everything. Engines, race cars, gearboxes, you name it. But Pacific have got 2 cars, 2 engines, 2 gearboxes and 2 bob.
It's no secret that last year, in our first year in Formula One, we didn't qualify, of course, for 11 of the 16 races. But we were operating on a budget of around about $5 million. And that's a figure which the vast majority of teams don't believe that it was possible to run on when you're buying your engines and all the rest of it. But Keith Wiggins was able to negotiate very competitive contracts. He was able to make sure that we had the resource to do what we had to do last year, which was to get a foot in the door of Formula One and to compete. And we turned up for all the races with 2 cars. We took part in practice and qualifying. We learned a lot. We tried our level best to turn the car into a competitive car, and we did compete in 5 Grand Prix. So we got to the end of the year, and I think for the budget we had, we weren't happy with what we got in the end, but at least we felt that we had given it our best shot with what we had at our disposal. Now for this year, we have had to at least double that budget. I mean, I think this year we will probably spend $10 to $12 million. We'd like to achieve $15 million in sponsorship, but I think we'll probably operate on 10 to 12, of which, you know, something like half will go to pay for our engine supply, and the engine supply, of course, is critical. Last year we used a relatively old version of an Ilmore V10 engine. We had reliability problems. This year, with the Cosworth ED, we've had 4 races so far. The engines have performed faultlessly. We get excellent technical support from them, and suddenly that variable has been eliminated, shall we say, from the list of problems that we had from last year. So, you know, you get what you pay for.
But even at the budget end of the pit lane, the level of technology required to stay on the back of the grid is frightening. Forget, if you can, about the needs of design and engineering. Just monitoring the car's activities during practice, qualifying and during the race requires the presence of more computing power than was necessary to put Neil Armstrong on the moon just 25 years ago, and Pacific have to muster every penny they can and all the help they can get.
The memory on the car is 2 megabytes, so I have to arrange the things I keep track of to suit the memory I have. All right. So what I do during the race is that I will keep track of about 20 or 30 parameters, which are basically engine and gearbox parameters, so that I can know after the race. If the race finishes, no problems. We don't need to look at it. But if there is a problem, then I need the data to know what happened. Okay. Now, if during practice and qualifying, that data I can get through the telemetry for the most part. So what I will do then is I'll keep track of more the suspension data, which is what we use to actually set the car up. So in that case, I'll actually be keeping track of more, up to 40 or 50 different parameters. All right, and these are mostly engine parameters. So basically all you want to know is whether the engine's still healthy, if you've got a problem type thing. There's a few other items on here. There's a gearbox pressure, and this one here is a gear number, so you know whether it's the driver, what gear he's in. You also have throttle position, which you wouldn't think you don't need to know that, but you do. And in fact, what happens if the driver has a problem, you can tell, what sort of problem it was, whether if he fell off or whether he was going flat out when the engine blew up type thing, or which hasn't happened. Hopefully never will. But if you see it, you can relate the items together so you know what's happening. When the car is driving around, there's a radio link which sends me back continual information. When the car stops, I then connect to the car with a cable, and that information is then what I use to analyze what has actually happened, and that happens within 30 seconds. All right, so anyway, I can take all that information and I can put it on the graph so that I can see exactly where I am at any one particular point. If I move the cursor here will move as well, so I can relate all the data. I get a number readout at the bottom. That tells me we were doing 205 kilometers at that particular point. These other two traces are actually the front suspension. Now, this is actually a 66 megahertz machine, but we're actually finding it's not fast enough. And so our sponsors, Hewlett-Packard, are actually supplying us with faster machines. So we're actually having the best that you can get.
McLaren also like to have the best, but they can afford it and build 95% of the cars themselves in-house, while Pacific do little more than assemble them.
We subcontract most of the manufacture of the car, and that works well for us because it means that if times are lean, we don't have big overheads here, and when if we're flush, we can go to subcontractors and get more things made. We can control things a little bit more that way, so it suits us in our current position. Jordon Grand Prix, who I was very lucky to work with for a short time when they moved into Formula One. I worked with them throughout their first season. I think in many ways paved the way for the smaller teams of the 1990s who came in, who were very ambitious, who have had their eyes set on challenging the big, what we would consider the big, bulky, very expensive teams of the 1980s. We think that that's something which is going to have to change. And Jordon, of course, in 4 years have come through from being a team exactly the same size of ours, with the personnel in the low to mid 30s, subcontracting everything in terms of the manufacture of the car. And Jordon now actually isn't that much of a larger team, even though they're a factory Peugeot team now. And they still subcontract a lot of their manufacturing. So I think that it is one way to do it.
There's an element of envy as the smaller teams look along the pit lane to the large ones with big budgets and posh factories, but you won't find it at Pacific, except perhaps in the ardent enthusiasm which they press their case upon potential sponsors. And they definitely believe they've got a lot to offer, although perhaps not in terms of hours and hours of television exposure.
We can do so much with the little budget that we have, but we know only too well what more we could do if the extra budget was provided. So we do tend to show existing sponsors and potential sponsors what we would actually spend our money on if they provide it to us. And at the same time, we try and work hard to show sponsors what we will do for them that the bigger teams perhaps won't do, because obviously we, being keener to show what we can do, we'll work harder for them. The big teams get the TV coverage, they get the media coverage. Their sponsors, chiefly the tobacco companies, will be very happy with achieving that. We obviously can't say to our sponsors that on a Sunday afternoon you'll be seen on TVs around the world for 2 hours, because they won't be. But so what we say is a Sunday afternoon's the icing on the cake. If we get coverage, if the cars, you know, are competitive in the race, that's the bonus point. What is important is how we actually work with them Monday to Friday, and that means an awful lot of work for us away from the Grand Prix, and a lot of planning a strategy for them, which means that, you know, at the end of the year they can look back and say, yeah, you know, we actually achieved certain commercial goals with the team, and on top of that, you know, they raced well on a Sunday afternoon as well. So it's really it's a 12. It's a bit of a cliche, but it is a 12-month program for all the sponsors that we work with. It's not something that happens some 16 Sundays during the season.
A larger budget is the dream of everyone in Formula One, including those who already count their spending power in tens of millions. On their present budget, Pacific couldn't afford to buy a full year's supply of new training shoes for McLaren. But that kind of pit lane perfection is beyond their ambitions, even with a major sponsor.
We feel that we know how we would spend the extra money if we got it to pull ourselves up. Money is a very important thing in Formula One. If you have money, you can do certain things with it, which should improve your position. Having said that, the people in your team who are spending the money have to know how to spend it wisely. It's very difficult to waste money, or very easy, sorry, to waste money in Formula One. And it's very difficult to find the right people who know how to spend it wisely.
Spending money wisely is not the object of the exercise. Formula One's like war. If you have to worry about how much it's all costing, you've lost. And for a team like Pacific, who've climbed the success ladder from Formula Ford upwards, going through every intermediate series, winning championship after championship, the harsh realities are sometimes hard to accept.
Having been used to being respected and successful at what we've done, then I would say last year was a bit of a culture shock. I think not qualifying was something I never even contemplated, but you know, people say, oh, you underestimated Formula One, and we didn't underestimate it, we just, logic said we couldn't be there. So we did it with whatever means we had, which was greatly under what was required. And we knew that, but we weren't going to get anywhere by just talking about it. So I think I had to adapt, but it hasn't really bothered me. I mean, we're just on a mission, and that's the way it is, you know.
Pacific are indeed on a mission, and part of that mission is to collect the necessary funds to do the job properly instead of just getting by. An extra $10 million would make the world of difference, and they know exactly what they'd spend it on.
We like to have 4 cars instead of 2, because with 4 cars you can have a car which is totally dedicated to a testing program. You've got a T car, so that, say, if what happened to us at the Spanish Grand Prix this year, where Andrea Montermini had a gearbox problem just before the race and wasn't able to start. If we had a T car, you know, we could have jumped in that. So you'd have 4 cars instead of 2. You'd also have a bigger supply of spares. We are, to some extent, marginal in spares in some areas. That's not to say if we had an accident we couldn't rebuild the car. I mean, of course we could, but you cut back on certain areas. So you'd have, for example, 2 fully built rear ends of cars, gearboxes, rear suspension and that, with you at Grand Prix, so that if you have a gearbox or a problem or an accident which involves rear end damage, you know, you can bolt the whole rear end back onto the car and have that as a spare component. You would develop a much bigger research and development program. You can spend a lot of time in wind tunnels, and for the bigger teams that obviously is a big advantage. They can spend literally weeks and weeks and weeks in the wind tunnel every time of the year. We have to really pick and choose when we do go into Myra's wind tunnel. We use the Motor Industry Research Association wind tunnel up at Nuneaton. So we have to pick and choose when we go in there. And when we go in, it's kind of very important we use each day absolutely to the full, because we don't have the resource to keep coming back ad infinitum. You would do a lot more testing. I mean, so far after 4 Grand Prix, we have only done 1 day shakedown testing at Snitterton. We haven't been to Estoril for a week. We haven't been to Silverstone running around, week in, week out. You would develop a testing program, and that means fuel and tyres and spare parts and the expenses of going and renting the circuits and that. So if we were given that extra investment from sponsorship, the whole picture of Pacific would change, because we'd suddenly be able to afford the things which the bigger teams take to some extent for granted, and we'll be able to develop ourselves into a much more aggressive Formula One team.
The fact is, you can spend any amount of money in Formula One, and the more your sponsors give you, the more you spend. And you have to. Running a race-winning team costs more than most of us can dream about.
A lot of money. Money that we don't have enough. We always try to find it. A lot of money. It's difficult to put it. How much costs an operation like that is how much you got in the budget. I can guarantee you that whatever you can find is what you're going to spend. And sometimes you spend even more than what you find. But it's difficult to actually put a figure, because if I got 10 more millions than what we have at the moment, for sure we're going to spend. So straight away you're already increasing your cost. You never stop. We keep loading things, we keep developing things, and in reality the limitation today is budget. The more money you get, the more you can invest in research, in more people, to get the best people. So it's difficult to actually put a figure.
Just back with the team from testing new suspension parts in France between Grand Prix, Ken Tyrrell knows only too well that extra money for development is exactly what does keep the big teams one step ahead of those who occupy the middle rank of the Formula One grid.
I think that's also true, but I think that the higher the technology, the further ahead, the higher the technology that's going to be permitted, the further ahead the teams with the big budgets will be.
Tyrrell have been in business for 25 years, collecting 3 world crowns along the way. But race wins have been thin on the ground in the 90s, though the team has an unmistakable air of confidence about it now.
I think people like to work for us. Perhaps partly because of our setting here, right in the middle of the green belt, where we're not on a trading estate, and partly the way we like to keep the team effort going, and it in Grand Prix racing is so much dependent upon a good team effort.
Tyrrell is also a busy place. Getting 2 cars to the start of 16 Grand Prix a year is a full-time occupation for a factory employing more than 100 people, and imposes a workload that needs to be carefully monitored.
Everything is on computer. There's records of every component that we make. Most of the things on the cars are life. They have a system where things are taken off the car after they've done so many kilometres and are fitted back on again, new parts. So the whole process is logged. Every component has a part number on it, and that's all on computers. That is really down to the production manager to coordinate all this with the sub-assembly, etc.
Like Formula One's so-called Big Four, Tyrrell make 90 to 95% of the car themselves in-house.
We get machine parts in that belong to each individual job, but then we make up virtually everything else that goes on the job by hand. As you see, there's tubes over there behind you that we basically form ourselves and then trim and cut in. All panels on the car are handmade. All panels that belong to jobs in here, be it uprights, the wheel uprights, are all handmade and then welded on by ourselves.
The list of components made in-house includes all the millions of items which go to make up a race car, and they must be made to minute tolerances, so that there's no difference between 2 similar items that were made on different days by different people.
No, because they're all still made to a jig. It doesn't matter who makes them, they are made to a jig, so that they all should all be identical anyway.
An engine deal with Yamaha is one of the reasons behind the Tyrrell resurgence. Factory engines are worth millions to a race team. And the sponsorship which came on board with Mika Salo this year has given Tyrrell the extra money needed to run a test programme of its own. The cauldron of Formula One doesn't allow for experimental systems in races, so development work must be done at test sessions by those who can afford it. Those will always be the biggest and the best funded teams, and now you're looking at the most significant advantage that a big budget can buy: track time. Generally speaking, the framework of a system of rules means that the propensity of one car to be better than any other is a function of its design, and no amount of money can buy you good ideas on a dependable basis. You can employ people with a track record of innovation like John Barnard, Harvey Postlethwaite or Gary Anderson, for example. But no matter what you pay them, nor what facilities you provide them with, you simply can't make them have race-winning ideas or build championship-winning cars. From the outside, McLaren's MP410 would seem to be such a car. What you can do, and what McLaren did, is to take the baseline product and try to refine it into a winner. But that's a process involving enormous manpower and money. It requires a full-time test team with its own cars, drivers, mechanics, technicians and budget. Then you can go away to racetracks that have good weather and test new ideas, different settings, new components, and even rehearse necessary race elements like the complicated choreography of the pit stop, complete with tyre change and refuelling. Pretty in slow motion, it's breathtaking at real speed. Williams is another team which began the 1995 season with expectations high, and at first their hopes seemed well founded. But within the space of just a few Grand Prix, it was clear there was a reliability problem and that Benetton had managed to effect dramatic improvements in the performance of its own car. For any team not in the Premier League like Williams, that could easily have been the end of 1995. But Williams are front runners and do have the financial muscle necessary to go testing week after week. So Damon Hill was able to climb from his car after the Canadian Grand Prix and say, we need to get this fixed, and find that 3 weeks later at the French round of the series, it had been fixed. He still hadn't beaten Schumacher, but he finished second, and the effort the team were putting in behind Hill and Coulthard was visible to outsiders. Currently at the top of the Premier League, Benetton's effort is clearly visible to anyone who visits their headquarters in Oxfordshire. On this 17-acre site, more than 200 people labour away in the kind of isolated splendour that concentrates the mind. And just one look at the place tells you it was conceived by someone who asked only one question: how much to win the World Championship, and then wrote the cheque as soon as he was given the answer. The results took a while coming, but they're here now, and you can understand why Benetton have no shyness about putting them on display for the benefit of any visitors who walk through the door of a factory built with winning in mind.
It's definitely a positive sign of the Benetton family wants to be in Formula One with the concept of winning races to be world champion, and that's what we've done last year, and we hope we can maintain that for the next following years. No doubt. So the size the Benetton at the moment okay, you said Pacific is probably another side of the scale. Then you got Ferrari, which probably is around 500 people. You got McLaren, which probably 350 people. Williams, I know, is a lot more than us, probably around 300 people. So we are what we believe is the right number to do the job right.
But Benetton too employ large numbers of people. Like the rest of the big four, they do as much as they can in-house, which is why the number of staff here is about 4 times the number of people going to the race.
We go around 45 people, including marketing. That's the normal number. But to split the company, you can say, okay, around 40 people in design, 40 within design, R&D and electronics and wind tunnel is around 40 people. Then you got probably another 130 people based in the factory, more or less. And then you got the rice team and the testing and the marketing and the accounts. That's basically how the company is split.
Though Formula One appears in public on just 16 weekends a year, the task of preparing the race cars is year-long.
We produce normally around 7-8 cars a year. It depends how many times you do during the season, but obviously it's an evolution of the car every 2 weeks. You know, every race that we go is something new comes apart. But as a chassis, if you don't have too many chances, you probably do with 8, 7, 8.
Once again, you get a glimpse of the massive industry which supports the Formula One race programme. And you know why the top teams are often collected under the heading of the Big Four. They each employ 100+ people in a massive, purpose-built factory, and each of them have a financial turnover which cannot possibly be less than $50 million.
Now we know, we believe that we can do it, and we can do it again, and we can do it again. And we established as one of the top teams, the Benetton in the past was never been established by that. So you obviously you're working already in totally different perspectives. You don't go races for finish in the points. You go there with the concept of winning the race. And if you don't win the race, you get very upset. So this is the difference when you are in the top and when you are in the middle or in the back. Is when you know how to win, or you've been able to win, you enjoy winning, and the number 2 is the first mover basically.
At the Science Museum in London, McLaren International launched their Neil Oakley designed Challenger for 1995. Typically of McLaren, the car bristles with new ideas and high technology in engineering, electronics and aerodynamics. McLaren put high emphasis on the fact that the MP410 has a higher content of carbon fibre in its manufacture than any previous McLaren, or they believe any other current Formula One car. But that's only part of the story. This is a car of many parts, and what you're about to see is an unrivaled look at exactly how McLaren put it together.
Good afternoon, McLaren International. Yes, have a line, please.
This is McLaren at Woking in England. This is where we design and build the Marlboro McLaren Mercedes Formula One cars. Let's go and have a closer look inside. This is the reception area of McLaren International. The trophies represent 4 decades of involvement in Formula One and 104 Grand Prix victories. These are the cars that have achieved most of the Grand Prix victories and represent the Formula One evolution of Formula One design from the early 1980s to the mid-1990s. This is the McLaren Research and Development Department. It's here they're working on ideas not only for the current car, but also new ideas for the future. We have in here a special cooling wind tunnel that's used for testing the cooling efficiency of the radiators. We have the model shop for the 1/3 scale models and materials testing. And here, this is the Instron 4-post test rig, where it's possible to monitor a car's performance over the whole duration of a Grand Prix in simulated form. This is the design office. The 1995 Marlboro McLaren Mercedes is designed 100% on CAD/CAM system. It takes 3 months from the start of the design through to completion of the manufacturing process. CAD/CAM is computer-aided design and computer-aided manufacture. The car is designed with computer vision CAD 5 software on a Sun Spark station. There is a direct link from the design office through to the manufacturing area downstairs, and it's an integrated network to minimize the time delay and also to avoid data misinterpretation. And now we're going to go into the factory and see the race bays, where after each race the cars are completely stripped down and then totally rebuilt. Here you see the cars that have just come back from a race. They've only arrived back the day before. Now they're totally being stripped down. This has just come back from a recent race. It's now being rebuilt. The gearbox has been taken off. They're taking off all the suspension parts. The carbon fibre suspension will be taken to the R&D department to be proof tested, and then the lower suspension will be crack tested, and the whole of the gearbox will be completely rebuilt in the gearbox department. To make sure that the gearbox is very compact, the reverse gear is actually positioned outside of the actual gearbox, and then for starting the car, the starter plate goes into this section of the rear part of the gearbox. The engine is mounted as a fully stressed member of the chassis, and you can see here that the engine is mounted onto these 6 bolts, and bolts directly onto the back of the chassis. There's gold leaf on the back of the chassis here to reflect back the heat back into the engine away from the fuel tank. The fuel is kept in a bag tank, which is inside here. This is made of a rubber and Kevlar material. It's self-absorbing in the event of an impact. And after each race, this will be completely taken out of the car and inspected. This is the section where the fuel housing will go in when they're doing the refueling structure. You can see here on the back is where the electronics will actually be bolted. And this is the deformable structure, which is to protect the driver. This is made of hollow carbon fibre. It is then injected with a series of silicon balls, and this actually has to go all the way to America to be injected, and then is brought back and then bonded onto the chassis. This is a new element that's been introduced in the regulations in 1995. Behind the driver is a self-absorbent pad, which is designed to cushion the driver so his head should not hit the back of the chassis and cause injury. If you press it softly, it goes in very softly. But if you hit it, it absorbs all of the impact. As you can see, there's not a lot of space in there for the driver. There's only sufficient space at the front for 2 pedals, the accelerator and the brake, the clutch being mounted on the steering wheel. The dash would normally fit on here, and then the steering wheel will bolt directly onto this column here. Often the driver will take the steering wheel out of the car to get out for ease, but all of the electronics that are on the steering wheel are mounted straight onto this point at the front here.
Like the other big teams, McLaren has its own machine shop where it can make engineering parts from scratch, out of forged bar and rod, or from castings which are bought in. McLaren also make their own carbon fibre parts, another facility they have in common with the larger and longer established teams, and it's worthy of examination all by itself. Later on, we'll be at DPS Composites, the biggest and best known independent supplier to the British race car industry, who manufacture components in sizes ranging from tiny to huge.
Carbon fibre is extensively used in the car's construction. This is the chassis area of the car. Carbon fibre is about 5 times the lightness of steel, but about twice the strength. And the whole weight of this chassis is about 40 kilos, and it will take about 10 man days to actually build a new chassis. And this is the fuel tank. Very light. It's made of rubber and Kevlar. Extremely light. You see it's made of flexible material, and this will be taken out of the car. In fact, this is a much smaller tank than we've had in previous years. This is only 130 litres, whereas in previous years it's been 230. The reason is for the reintroduction of refuelling. Interesting thing, it's flexible. It's not like a normal road tank, which would be made of a solid material. There is no ball in there to check the amount of fuel that's actually left in the tank. What actually happens, how they measure the fuel flow, is it's done by counting the number of squirts effectively that go into the engine, to count the injection, and this is calibrated by computer, so you know what the fuel flow of the engine actually is. This, after a race, will be completely taken out, checked, and then squeezed up and put back into the chassis.
The focal point of interest in the tub isn't, of course, the fuel tank, but the driver and his environment, basically a dashboard and steering wheel.
This is the dashboard of the car, been made of carbon fibre. This is the rev counter. It starts at 6,000, goes up to 17,000. The operational rev range of the car is about from 13,000 up to almost 16,000 revs. The buttons here, this is for the neutral button for the gearbox. The hollow section here is for altering the front and rear brake balance. This is for the fire extinguisher in the event of there being any fire, for turning the ignition on, a switch for monitoring the radio, for turning the volume up and down, the lights that are used on the rear of the car in wet conditions to be able to turn those on, and then switches the drinks button. It has the facility there, but so far this year the drivers haven't actually used it. This is the steering wheel from Nigel Mansell's car. The buttons, this is the button for controlling the pit lane speed, because you have a cutting, so they know there's a 120 kilometre speed limit in the pit lane. The middle button is for neutral, and this switch here is for the radio. And then these two switches are for the fuel and for the gearbox. The driver changes gear by two flipper switches that are on either side of the steering wheel. On the right-hand side is to change up, on the left-hand side is to change down, and it's a semi-automatic 6-speed gearbox. The bottom two buttons are the clutch. The car only has the accelerator and the brake, and being semi-automatic, the clutch is only needed to actually start the car. The reason we have it on either side, depending on whether the driver's spin, he can easily move his hand to inject the clutch. And on the top here, this is the quick release button for the steering wheel for the driver to get out, and all the electronics for the steering wheel are controlled down the centre section here, which plugs straight onto the steering column.
That's almost a complete car. Later on, we'll follow the engine to Ilmore and consider engines separately, so the only thing left is to paint it up and send it on its way.
This is the paint shop preparation area. Here are chassis being prepared. We repaint the chassis every 2 to 3 races. We're very careful with the amount of paint that's actually used on the car. Maybe only 120 microns to save weight.
The money and the manpower is all aimed in the same direction. In Formula One, the name of the game is winning and nothing else matters. Second place is just first loser. And a latest Montreal win puts Ferrari back on top of the list of all-time winners with one more victory than McLaren. By far the most secretive team in the pit lane, Ferrari is also the most successful, with 105 Grand Prix wins to its credit. But then the team was established in 1948, and Enzo Ferrari's personal credentials go back to the Alfa Romeo team of 1926. But Scuderia Ferrari lost direction after the death of Il Commendatore and endured a wilderness period of 59 races without a win until Gerhard Berger broke the drought at Hockenheim in '94. Now, with Formula One's most powerful engine, a 17,000 RPM Screamer, plus a beautiful and increasingly effective chassis created in Guildford by John Barnard, Ferrari are on course for further success. with Luca Di Montezemolo at the top, Jean Todt organising the race team in the way only Jean Todt can organise a team, and Nicky Lauda adding his own expertise. Ferrari saw Lacey take his first Grand Prix victory in Montreal in 1995, and there were clearly more to come. Although budget can scarcely be a problem for Maranello, they still maintain close links with the UK. Design guru John Barnard still works from Surrey and uses local contractors for items under development. Spend any time at Heathrow's Terminal 1 and you'll soon spot the couriers hand-carrying unwieldy shapes onto Alitalia flights. Over a period of time, almost every team has called on the services of DPS Composites, a Surrey-based company which makes carbon fibre parts for every formula you can think of, and a vast range of other items. Carbon fibre was invented in the 60s at what was then the Royal Aircraft Establishment at Farnborough by three British scientists, Leslie Phillips, Bill Watt and Bill Johnson. They were part of a team searching for ultra-high-strength materials for aerospace usage, and they came up with this very light and strong textile material which relies on the correct alignment of carbon atoms, the very building blocks of life itself, and a curing temperature of 5,000 degrees centigrade for its creation. Nowadays, carbon fibre is the building block of Formula One. 10,000 tonnes of it are produced annually for medical, sports and the aerospace industries. But carbon fibre is the literal backbone of Formula One, having taken over from aluminium as the material of choice.
Yes, it's a better material in a lot of respects. The other advantage is you can actually mould very complex shapes a lot easier than you can form flat sheets of aluminium into complex shapes.
On the other hand, it's not easy to work with, requiring special skills and special equipment, and it's far from cheap.
It's a relatively new skill, so the labour rates are reasonably high. There's not that many good carbon fibre people around. The material itself is quite expensive. For example, a square metre of carbon cloth would be in the region of £25, and that 1 square metre will produce a sheet which is only 10,000ths of an inch thick.
All of which puts the price of components the size of floor pans into some kind of perspective.
Depends what you're building. If you're building a small, simple component, such as a brake duct we have here, it's 2 or 3 layers of the carbon cloth. There's no honeycomb or no section to it. But being a small component with lots of shapes, it's plenty strong enough. If you're building, for example, a Formula One chassis, which has to withstand much higher loads and the various crash tests that things have to go through, you build it in a sandwich construction, which is a skin of carbon fibre, and then a piece of honeycomb which may be 10, 15, 20 millimetres thick, and then another skin of carbon fibre. So you're actually forming a thick section, but at the same time it's very light and very strong. Basically you put it in a bag and suck all the air out, which provides a vacuum, which is 1 atmosphere, 14 pounds per square inch on the bag. You then put it in the autoclave and pressurise the autoclave up to maybe 100 pounds per square inch. So that's the extra pressure you're providing. And it needs to be in the bag to actually squeeze it all together. The autoclave provides the curing process. The resin, depending on the resin system we use, but basically the normal resin system cures at 120 degrees centigrade. And it takes about 4 or 5 hours for a cycle. By the time you've heated it up, kept it at 2 hours at 120 degrees, and then cooled down.
If carbon fibre has a drawback, it's that components made from it can't be altered. An aluminium part can be amended by a craftsman, but the dimensions and shape of a carbon fibre part are unalterably fixed once it's been made. That means that, except in extreme emergencies like the one affecting McLaren and Mansell, the size and shape of major items like tub and chassis parts tends to be settled soonest and least amended.
Chassis-wise, most of the teams, I think, pretty much finalise it fairly early on. Things like wings and bodywork and floors constantly evolve, depending on how good the car is.
Because of carbon fiber's unchanging nature, you must be certain that what you make is dimensionally exact. And DPS must be getting it right, because over a period of years they've made parts for just about everyone in the business.
McLarens, Saubers, Penske's, their Indy cars, LaRousse, Lotus, and various other ones.
Some teams make their own carbon fibre parts. That list now includes Benetton, Williams and McLaren, and also Tyrrell, whose manufacturing process we've been looking at. It's complex and requires specialist equipment, but apart from that, it's a system that would be familiar to almost anyone who's filled a dent on their car with a fiberglass filler.
The basic process is the same as regular fiberglass work. You have a resin, you have a fibre to reinforce that resin, and it's cured either by time or by heat. But our process takes a lot longer because of the types of resin we use. The whole cure cycle in the autoclave is 4 or 5 hours, and the manufacturing time for a component can be anything from a few hours to several weeks, depending on the complexity of it. A chassis, for example, Formula 1 chassis, there's something like 1,100 man-hours in each chassis.
But it would take ages to make a floor pan from P38 too, and it would be heavier, and it would break when you picked it up, which may explain why carbon costs £25 a square metre. (1995) saw a brand new regime of regulations which obliged everyone to start with a clean sheet of paper, or more likely, a blank computer screen, to create their new cars for the season. At Williams, Adrian Newey was the man with the task of creating their new challenger for the year, and with some success.
Obviously there are a number of things that have been changed since last year, to do with the regulation changes, aerodynamics side, and Adrian Newey and his people on the aerodynamics side have come up with a different layout for the car because of the constraints of the new aerodynamic regulations, and as we were saying previously, the results on average seem quite good.
Harvey Postlethwaite said those regulations established criteria in which aerodynamics were no longer the sole priority, and they were a positive benefit, an opinion not universally shared.
I think they were done in a bit of haste, really. They haven't done any harm, but I don't think they've done as much good as really they should have done. A bit more attention should have been put into them before they were finally defined. I think now the FIA are finding some of that with some of the testing they're doing at Myra, that really the safety aspect is not as big a step as what we all thought.
Directed by Postlethwaite, Tyrrell have veered away from the quest for downforce produced by cunning interpretation of the rules and are looking elsewhere for mechanical grip, hence the new and still secret Hydrolink suspension system and the possible inclusion of last year's viscous coupling diff to help get the car off the corner better. Less downforce means less traction, means less grip, and putting the power down out of a corner is where it will hurt the most, and that's where Postlethwaite and the team are looking now.
I think that we've had a massive amount of work to do over the winter because of the regulation changes. All new cars for this year, all Grand Prix cars are new this year. And we hope that these regulations will be kept stable for a few years now, because it will enable us to develop the cars we've got rather than having to build all new ones every year.
Yeah, the regulation changes meant that we really had to start from the beginning. They moved the driver around quite a lot for safety reasons. and aerodynamically the car has some very big changes to reduce the downforce from the cars to reduce the speed around corners.
The obvious reason for that is that regulation changes, which are as sweeping as those the teams were obliged to adopt for 94 and 95, are not cheap to implement. Only the well-funded teams also have the budget to exploit them, as opposed to just adopt them.
Every time you change a regulation, particular radical change like we've done this year, means there is very little you can use from the previous years. So that means a totally, completely new car. And obviously it's a cost implication in there. If the regulation is stable, some of the part of the car you may use it for the following year. Well, it's the concept. At least you don't spend the time to design and to develop.
The problems posed by regulation changes for 1995 don't only affect the chassis designers and aerodynamicists. They involve the engine makers too, as the new 3-litre formula imposes its own set of imperatives, as well as allowing designers more freedom in other areas.
We have done a complete redesign of the 3-litre engine. We are one of the only manufacturers which have done so. I guess the decision was made together with McLaren because of the step bottom they have in the car. The step bottom is over a width of 300 to 500 millimeter, and we built the engine in a way that it fits that particular aerodynamic package.
Like the car designers, Mario Illien now believes that stability is essential for future development if there is to be real benefit for consumers from Formula One, and that the 3-litre formula will lead to more improvements in the future.
I think nothing is ideal, but at the moment the decision has been made. We are on a 3-litre engine beyond the year 2000, and I think it's important to have stability, and that's what we have to live with. And I think it's very good to have made that decision, to have for several years an engine where we can build and develop, rather than changing the specification every year, which is obviously an extreme cost to everybody, and I think it will probably even drive some manufacturers away from racing. Yes, obviously you have the choice of 8, 10, 12. V configuration, I think, is almost a must, because the chassis and the engine are as a bolted together unit, so the engine is taking all the chassis load from the rear axle to the front of the chassis, and you have to make a stiff package from a torsion point of view as well from a bending. So you're almost forced into a reconfiguration.
The car designers share Mario Illien's feelings about stability, especially after such a long period of it was followed by frantic changes, putting design teams under enormous workloads.
Because it's such a big change in the regulations, you know, we've got a small team here really, relatively, and we've got 8 people in the drawing office, and we haven't got the manpower to catch up with the other people that have got 3 or 4 times the amount of people. If the regulations are fairly stable, then we can catch up slowly on them, because there's not really that much room for them to go ahead. But because the regulations are so different, at the beginning of this year everybody had a baseline car to the new regulations. You know, Williams, Benetton, Ferrari, their cars now are completely different from what they were at the beginning of the year, because of the manpower and the money they have. So we haven't run forward as fast as they have. So in effect we've gone backwards, but we're hopefully going to address that situation quite quickly.
But the changes were made with the very best of intentions, though some seemed almost inconsequential, like the 1/4-inch thick sheet of wood under the car, which looks unlikely to make that much difference.
The reason that regulation was put in last year was to stop the cars hitting the ground so hard. A lot of people, drivers and they were complaining about the fact the car was just beating itself to death on the ground, and because of that you could get some mechanical failures. The reason it was put there was to be a piece of wood underneath the car, that you could only wear a certain amount of it. And it was a pretty good regulation, I believe, to control the car from hitting the ground. It lost a little bit of downforce because of it being a step underneath the car. So all in all, it was a reasonable way to go. But then a lot of people had problems because the car was hitting for whatever reason, wearing it away, and at the end of the race, they were deemed illegal. Which was fact. That was the regulation, so it was fact. Everybody had the same opportunity to make it not happen. But after that, then, you know, the FIA changed its mind and decided that they would allow us to put skids, steel skids underneath the tank, Now we've got the plank of wood, we've got things to protect the plank of wood, and it's really a lost cause. The reason that thing is put there has been done away with. It's not really necessary anymore. I think the original concept was quite good because the cars hitting the ground all the time, it definitely does them harm, and it doesn't do the driver's spines any good. So I think, they shouldn't have changed their mind that quickly on it, but they did.
Some people feel that the changes have produced a backward movement and taken Formula One backwards and set it alongside IndyCar.
Yeah.
We've gone back a long way. If you'd left the regulations alone as they were in the early 80s with the ground effect cars, you would have been seeing lap times, 20 seconds quicker than what they are now. So you have to drag it backwards every now and again. Comparing it to Indy cars is a very difficult thing. I mean, it's a very different discipline. It's like comparing soccer and rugby, really. You still play with the ball, but the aim is different. We have had to build a new car for a new set of regulations, and it meets the criteria that the FIA want. Indy cars is doing it for a completely different reason. They are a customer car company sport. We are trying to do it as a business, individual business. Whenever we run the races, there's 13 different teams, 13 different cars, whereas Indy cars, there's probably 2 different chassis running in a race. So it's done for a different reason. IndyCar regulations are much, much more controlled. There's the book with the regulations is probably 50 times what we have. But everything's defined in it. Our regulations are a little bit vague. So there's room for interpretation, which is really what you see all the arguments about the interpretation of the rules, not the actual rules. And everybody's interpretation of some of these things will be different.
So, as the FIA intended, things do seem to have taken a step backwards from the days when a car could glue itself to the roof of the Monaco tunnel at 100 miles an hour, and the 1995 regulation changes have produced exactly the desired effect.
This year's car against the car we built at the beginning of last year, we're probably running on about 50% of the downforce. Now, you're talking about that, you're still talking about creating at 150 miles an hour, sort of 1.5 tons. But there used to be an old philosophy of driving on the roof of Monaco tunnel, but I think if you try to do that now, you'd probably end up in the harbour. But I mean, it's just a matter of speed. It can still be done. You just have to make the car work more mechanically because you have less assistance from the aerodynamic forces. And I think as time goes by, I think by the time we get to the end of this year, we'll probably be in the same level as we were at the end of last year, which will be probably a 20% increase as the year went past. And I think then with winter development at one time or another, we'll come back again at it next year. But I think really the FIA will probably try to put a top on that again by doing something not as dramatic as it was for this year, but something just to sort of dot the I's and cross the T's, as I keep saying. I mean, it's just the same, I think, as building a vacuum cleaner or a washing machine or anything. It's an engineering product. You're trying to make it better, to do a better job. And ours is related to lap time, not the fact you can do a whitewash with 30-degree temperature water or something. It's the same thing, really. We'll always try to improve it. I don't think you'll ever see the day whenever the lap times will, unless the regulations change, but where the lap times will stop and not actually get any quicker. There'll always be development, be it in tyres, brakes, engines, gearboxes, chassis. There's so many variables there that you can always find that little bit.
The job of designing a Formula One car is more complex than it ever was before. No longer a one-man job, it's a team effort now, but as always there's one hand on the helm steering the ship, and that one man can still provide the inspiration and ideas which make a car into a winner.
Certainly Harvey has been an innovator, and at the time that he was with us he was certainly that, and before he came to us, and now on his return to us we are doing things that we weren't able to do before he returned, and the additional budget that we had from having Nokia on board is enabling us to do that.
Harvey Postlethwaite gave us the anhedral front wing, and then John Barnard made it the raised nose, which everyone else has adopted. The drawback is extra weight, and this year Pacific came up with their so-called platypus nose, with as much wing area as the raised nose but without the weight of the supports. McLaren came up with a controversial mid-wing, which many other teams had tried and discounted because it brought more problems than it solved. especially mid-corner stability, or rather instability. By Montreal, McLaren finally admitted defeat and dropped it themselves. Most observers felt its design purpose was more to do with airboxes than aerofoils in any case.
All the money and all the technology in the world won't replace somebody that's got a bit of a foresight. But to be honest, nowadays you've got to compete with a team. You can't compete as an individual, and the teamwork is what is a very important part of it. Each individual can come up with his own flash of brilliance on a given thing, but it has to fit in with the teamwork. You know, we all have to operate as a team. In days gone by, whenever a design team operated with maybe 3 or 4 people, there was room for one of those guys to have his flash of brilliance, but it only worked because he was a very big percentage of the team that was there. And now each individual is a much smaller percentage, so someone has to collect them together and head off in a direction. It's more, to be honest, it's more of an organisational job now than actually sitting down and thinking about what's the next step, you know, can we reach Mars or not.
A factory engine deal is worth a lot of money to a Formula One team, but there was a time when just about everyone in the pit lane had one of these. It's a Cosworth V8. Now it's only a few, as the bigger teams try to tie themselves with a big factory which will supply engines and technical support. Latching onto the Peugeot engine after McLaren pulled out of its deal with the French maker was a good move for Jordon. That leaves Tyrrell with Yamaha engines, and whether or not that's much of a coup for Tyrrell remains to be seen, but Yamaha's commitment to Formula One is clear. And the fact that Renault have chosen to supply 2 first-class teams with its engines is a decision viewed as controversial by many, and it's seen as a coup for Flavio Briatore, Benetton's flamboyant boss, and a blow for Frank Williams. That McLaren should form a Grand Prix partnership with Mercedes is viewed with mixed feelings. The Mercedes Formula One engine ought to be as successful as their world sports car power plant, but hasn't been. And the Mercedes engine is really an Ilmor power plant, designed and produced by the company which has had so much success in IndyCar that it's dominated the American racing scene for some time. But as we all know, Formula One's a different animal.
It's different, yes. In Indy, we have obviously Penske as our factory team, our Mercedes factory team. That is a similar situation. But then we have got several customers on top of that. So we are covering a much bigger market. And there are 3 chassis competing against each other. So the difference is really that you have got almost a kit car in some respect for some teams, and then building the car around the existing engines which are on the market.
Ilmor's a massive place, employing 200 people, bigger than most Formula One teams. And this is hardly a quarter of Ilmor's factory, a place so vast it now makes crankshafts in minutes, shortcutting a process that used to last months, and uses so much power it needs its own electricity substation so as not to black out the industrial estate and half of Northampton. The equipment and commitment evident here make it obvious why Mercedes and McLaren are happy to be involved. But even so, McLaren's take-up of 68 engines in a season is massive, almost equal to the entire IndyCar programme.
We have expanded a little bit during last year and this year, and I guess we still have to expand some more. But it's not really changing the way we have gone forward up to now.
The degree of care in manufacture is almost unbelievable. This machine, built by Zeiss, has components for inspection bolted to a 5-ton block of granite that floats on computer-controlled blasts of compressed air in order to eliminate vibration, and it has to. The ruby-tipped probe checks components as mundane as water pumps and alternators to tolerances as low as 0.2 of a micron. And a micron, in case you've never seen one, is about 1/50th the diameter of a human hair.
I wouldn't say it's better than any machine, but you need obviously the human element. You need still the brain power to make the machinery working. And I mean, you see we have computers around here, but you still have to have the right input. Otherwise you're not going to get what you want. And that's where the human element comes into it. You still have to think as hard as you did before, even you have a computer helping you.
The modern Formula One engine is an intrinsic part of the car. It's a stressed member that becomes part of the chassis once it's bolted into place. Its size, weight and position will all affect the nature of the car as a package, and it may not be that much longer before engine designers sit side by side with chassis designers when a new car is created.
No, I wouldn't put it to that extreme. Obviously, there is still an interface between car and engine, but the package, I think, is to a degree developed together, because they're finding out from their aerodynamicists what is important, what is giving them a gain. And the next stage is how can we adapt the engine to get into that package best, or we find a benefit on the engine, and then the question is how can we adapt it into the car without compromising the car's aerodynamical performance.
The other thing that can't be far away is the advent of new materials like alloys and ceramics in engine construction.
I think ceramics less so. A lot has been talked about ceramics, but you can use ceramics in some areas for reduced wear or reduced friction, that type of thing, but not to the degree people were talking about it. I think that was a little bit of more talking than actually what's happening in reality. But new materials for sure will come in, but I think they're more in materials, composite materials, fiber reinforced materials and that sort of thing.
It takes about 6 months to design and build a new engine from scratch to prototype, and about 2 weeks to make each one once the program's established. Ilmor do the lot from start to finish, buying very little apart from castings and electrical components needed to assemble things like the £12,000 wiring loom for the fuel injection system. In fact, there are about £50,000 worth of electronic parts on the engine when it's completely assembled, and then it's put in its little box and sent back to McLaren ready for another weekend of racing or testing. The 1995 regulations put strict limits on tyre usage at any race meeting. All drivers are limited to 7 sets of slicks per weekend, making their allocation another tactical weapon in the race strategy. There are a few other ways in which tyres can be used to win races, or at least bid for race victory. All Formula One tyres are now made by Goodyear and conform to the regulations which allow a maximum width of 15 inches and 26 inches in diameter. The factory produces about 25,000 tyres in total, and around 13,000 of them will be used in Grand Prix during the season. Another 7,000 or more in testing by teams and by Goodyear themselves. Before each race, Goodyear decides whether the circuit calls for one dry compound or a choice of 2 from a range of 4 possibles. They'll take 900 tyres if it's one choice, and if necessary add a further 600 tyres of a second choice compound. And they always take 600 rain tyres, so they'll have between 1,500 and 2,100 tyres at any Grand Prix. They've been racing in Formula One for 30 years and have won 300 plus races, as well as 300 plus pole positions, 22 Drivers' World Championships and 23 Constructors' Crowns as well. Far from freezing development, Goodyear's tyre monopoly has led to a stable situation in which the development engineers have been able to work on producing constructions and compounds which have been demanded by car designers like Harvey Postlethwaite, who can no longer rely on aerodynamics to produce grip, but must find higher levels of mechanical grip to compensate for the regulation-enforced reduction in downforce. Goodyear's commitment to Formula One in terms of finance and personnel is considerable and continuous. Despite the enormous publicity which Formula One racing receives worldwide, it's difficult to see how there's any direct benefit for the company being involved in a program of this nature. Goodyear have adopted a direct strategy and named their race tyres and their road tyres Eagles and hope for an immediate marketing link. Regulation changes affecting the whole of Formula One have also affected the tyres, as we've heard. For example, the fuel stops which take place in the races now mean that tyre changes happen as well. So the tyres themselves no longer have to last a whole race, but at most only half of it, or maybe even only a third. Even though the limiting factor is the speed at which the fuel tank can be topped up, putting an end to McLaren's 5-second tyre stops, the pit stop is still a 10-second affair. And the intricate ballet of the technicians as they lift the car on jacks, remove 4 tyres, fit 4 new ones, and add 100+ litres of fuel is still fast and furious. The sheer scale of a top-class Formula One operation is breathtaking. While smaller teams may operate on $10 or $12 million, there are others who spend that much money on the driver alone.
I think some of the drivers are still overpaid, so I'm not sure I would I would pay even if I had the ability to. But certainly some of the drivers you're probably referring to that I've had, I'm sure they're not in the highest paid league at the moment. And I'm a great believer in giving the young guys a chance. If I was in the position, some of the teams, obviously politically, you come under fire from your engine suppliers, your sponsors, and there's lots of things to consider when you're in that level. But I would always try and go for the younger guys, and if I had the money to do it, I would pay the guys that I thought were worth it. Fair pay.
But there's no doubt that a good driver is definitely worth paying for, especially since the regulations mean 1995 cars are a return to the days when a driver's sensitivity and natural talent makes more of a difference. Robbed of fly-by-wire gizmos, these cars are ideally suited as a showcase for drivers who have innate ability, like Alain Prost, and bitterly ironic, the untouchable Ayrton Senna, and as a bonus, they're more entertaining to watch and to drive.
Yeah, I would say that they would enjoy driving them more at the moment because the car will move around quite a lot more, you know, it'll slide about more. It's like driving in the wet. The car's sliding and you're not going so quickly. I think it's brought a level of driver that has to have more driving finesse. You know, the car hasn't got the grit, and there was some of the drivers that used to drive a few years ago. And I mean, they drove with the fact that the engineer was able to tell them you can go around that corner 10 miles an hour quicker. And they would go around that corner 10 miles an hour quicker because the car had enough grip to do it. Those days are sort of gone now. You're driving with a lot more feel, and I think that's where you see the confident, feeling driver coming forward. I mean, Schumacher's a typical example, Release is a typical example. I think they do a good job because they have a lot of finesse within the car. They're not just driving it on pure muscle. Pure muscle nowadays, I think, is gone away. You need some finesse.
1995 should have been a brilliant valedictory season for Britain's most recent world champion, but while McLaren devoted unimaginable effort into building a new chassis for Nigel Mansell, what should have been a beautiful friendship dissolved into bitter disappointment.
You got the history behind those quantities, because look at Mercedes, what a fantastic company they are. Ilmore, the people there, so you know the engine's going to be good. How strong it will be, we'll have to wait, but for sure, whatever power it's got, we're going to get more power as the year goes on. McLaren, look at the history behind that, fantastic. And I've got a little bit of history too, so together I think it's a formidable force.
Sadly, Mansell's history appears to have ended with his half-season at McLaren, but as the old guard makes way for the new, there's no room for tears. Michael Schumacher was one of 3 drivers who graduated into Formula One from the Mercedes training school, but he's the one who's emerged the strongest. And though Benetton looked to be the strongest team in '95, there's little doubt that Williams made the right driver choices for the season, choosing to stay with Damon Hill and bring in David Coulthard.
Very pleased, undoubtedly. I mean, Damon is showing a continuation of the speed and maturity that he showed in the last 2 races of 1994, and really one's view of Damon continues to be enhanced with every race that he does. He's got an amazing record for, I think, 11 race wins out of 36 or 37 race starts, but really only 34 or so race starts in a reasonably competitive car. And David, obviously still not having completed a full season of Formula One, it's remarkable to be running up at such a high level, near or at the front. And okay, there have been one or two little slips, but I think that's only to be expected so early on, but we're all expecting very good results from him for the future.
That opinion is largely shared by Frank Williams, who knows that the future of his team and others now depends, at least in part, on its ability to recognise and attract young talent, and that the Hill-Coulthard pairing reflects that.
Well, you use the word maturity. He is that. He has become a very mature driver who is accustomed to winning. And the significance of that is that he's able to handle being in the lead. He knows how to come from behind to attack and obtain the lead. And whilst in the lead, he's less likely, because it's not an all-new thing for him, to make mistakes and lose control. We're all very keen to see David join the team for this year. There's no question that the decision that was taken was the right one. No question at all.
But are Hill, Coulthard, Schumacher, Hakkinen and Lacey the only new Premier League drivers of Formula One, or are there others? Given unlimited budget, who would the team owners employ? Who would they choose if they were to play Fantasy Grand Prix?
No, you can't ask me that, because Formula One is not dealing in fantasy. It's dealing in the true facts of life.
Well, I'd start with Bertrand Gachot and Andrea Montermini. I'd be happy to see people like David Coulthard. I'd like to see Christian Fittipaldi again in a car. I know a few, Jordi Genet, a Spanish driver, I believe, had a lot of the talent. It would be quite interesting to have the ability to go around and pick what you think is a good driver. I still believe there's potential in people like JJ. It's all a question of the right environment to develop. But I mean, there's a number of young drivers. If you said to me, who would you pick out of the top boys, that would probably be a harder one, to be quite honest.
Nigel Mansell's not on your shopping list?
No, Nigel Mansell wouldn't be on my shopping list. Motor racing's never been fun for me, actually. I don't know if I've ever enjoyed it. It's a challenge, and it's only good when you're winning. And if that happens, you always want to do better. So therefore, it's a drug more than it's a need more than something that's fun.
I disagree with that. I think it's always been fun, and the only reason that we've been in it for this last 27 years. Is because we find it fun, and we are very fortunate in that we've been able to earn our living doing the job that we like doing.